Okay, in this video, we're going to talk about the properties of equality, and you've actually used pretty much every one of these properties to solve equations, but we're going to introduce you to you because we're getting ready to start proofs and how to prove that things are true. So let's go over these properties. First one, the addition property of equality. Now let me just go through and kind of show you when you've used this before in the past. When you're solving an equation, if you have two things that are equal, the addition property of equality says if two things are equal, you could actually take and you can add anything to one side of an equation as long as you add it to both. Look what happens. 3 plus 1 is 4. 3 plus 1 is 4. Down your equal sign. It stays the same. The second one, the subtraction property of equality, works the same way. You can subtract anything from one side as long as you subtract it from both sides, and you end up with equal statements as well. Multiplication, you can multiply anything by one side as long as you multiply it by both. So these are these properties of equality. So the addition property of equality says if two things are equal, if A is equal to B, then you can take A and you can add C to it as long as you take and add the exact same amount to the other side, and they're still going to be equal. Same thing with subtraction property. If two things are equal, then you can take and subtract anything from one side. As long as you take it and subtract from both sides, it's still going to remain equal. And that's the properties that we've just went over. The multiplication property of equality says if A is equal to B, then A times C is equal to B times C. I've multiplied both sides by the same amount. Division property, if A is equal to B, then A divided by C will equal B divided by C. They will stay equal as long as you do the same thing to both sides. The distributive property is the property we use to get rid of parentheses. If A parentheses B or B plus C, if A times B plus C, then A times B plus C will equal A times B plus A times C. So we can get rid of those parentheses by multiplication. The substitution property, same way with sports, when you take a player out of the game and you substitute in a player in their place. So this property says that if A is equal to B, then A may be replaced. Same way that if two players play the same position, then one that can be replaced by the other. If A is equal to B, then A may be replaced by B in any expression or equation, or vice versa. B could be replaced with A since they are equal. Reflexive, for any real number A, the reflexive property says that A is equal to itself. A is equal to A. The reflexive property, 3 is equal to 3, 4 is equal to 4. A value always will equal itself. And that might be, you might think, well, when will we ever use that? But we are going to use that in some of our proofs. The symmetric property says that if A is equal to B, then B is equal to A. Now, let me explain when you're going to use that. If you solve an equation and you come down to the end and you have 3 equals x, well, you can flip flop that around and say, well, then x equals 3, and that's the symmetric property. The transitive property says that if A is equal to B and B is equal to C, well, think about that. A and B are the same thing, and B and C are the same thing. So that means that A and C must be the same thing. The transitive property, it kind of transfers. A is the same as that, B is the same as that, so therefore A is equal to C. So now let's use these properties of equality. And we're going to use them in what's called a proof. This is our way of introducing you to what a proof looks like. We're going to be proving some geometric theorems, and we're going to be using these two columns, or we're going to be doing it using these two column proofs. So using the properties of equality can be used to justify steps in solving an equation. To justify, again, this is deductive reasoning. We have to have reasoning. We have to have reasons behind why we're doing what we're doing. And that reasoning is going to be properties. A two-column proof, obviously you see down here below, you see the two columns in this proof, column 1 and column 2 over here. A two-column proof, it says, is a common format used to organize a proof. There's other ways. You can do paragraph proofs. You can do other things. But two columns is probably what we're going to do most of the time. Left side, you're going to list the statements or the steps. the steps to solving. And then the right side is going to be the reasons that that is true. So we're gonna on the left side we're actually going to do the work, and then on the right side we're going to tell why we could do what we did. What can be used as reasons? Now, reasons is this stuff over here. What can we use as justification of why we did what we did? We can use properties, definitions, postulates, and theorems. Now, we will talk more about these as we go, but these are going to be the exact same thing that we're going to use for our reasons as we go through geometric proofs. Okay, so we're going to use these properties of equality to justify what we're doing here. Okay, let's try our first proof. And here's how it's laid out. Up here, here's what we are given. We're given that 4x minus 1 is 27. And somehow we need to take that given and prove that if that is true, then this is true. Wait a minute. That's that whole P implies Q stuff. We're given that this P is true, and we want to show that that implies that this is true. That this is our P and this is our Q, and we're proving we're proving implication. So we're given, and notice my first line of my proof, and it's always going to be this. The first line of your proof is always what you're given. It's this statement right here. So given that, and we're going to try to work our way down to this, which is always going to be the last step of your proof. So here you go. First, step number 1. If 4x minus 1 is 27, I know that I can move that minus 1 over by adding. So what I'm going to do to move it, I'm going to add 1. And we usually don't show our step, but technically what we're doing is we're adding 1 to both sides. Now, what property is that says that, and you can see here that those cancel and leaves me with 4x equals, the 27 plus 1 was 28. Why can we add 1 to both sides? There's reasoning behind it. That is the addition property of equality. That's that addition property that we just went over a couple of minutes ago. That says that you can take an equation, if two things are equal, that you can add the same thing to both sides and it's still equal. And then the next step, we go from 4x equals 28 to x equals 7. Now, how did we do that? Since 4 is being multiplied by x, to get rid of it, I divided by 4. Whatever you do to one side, we do to both. So that got rid of that 4. Now, what property says that we can divide both sides by 4? That is the division property of equality. So we now have, when we divide both sides by 4, we now have x left over here equals 28 divided by 4 is 7. So by taking your original statement and doing the addition property of equality to both sides and then doing the division property of equality to both sides, we go from 4x minus 1 is 27 to x equals 7, which is what we were trying to prove. Next problem. We're given that a divided by negative 6 plus 2 is equal to 5. And we're trying to somehow prove that a must be negative 18 then. Okay, the first thing that we're going to do, and notice here they've done the work for you. Okay, now later on you're going to have to fill in these blanks, but here they've done the work for you and you're just having to fill in the reasons. To go from here to here, notice what got moved. This 2. They subtracted 2 from both sides of this equal sign. What statement or how do we know that we can just subtract something from both sides? That is the subtraction property of equality. And then all of a sudden we have this statement that says a divided by negative 6 is 3. Well, to solve that, how do we get rid of division by negative 6? We're going to take both sides and we're going to multiply by negative 6. And you're going to get 3 times negative 6, which gives you that negative 18. Well, what says that you can just take and multiply both sides? That would be the multiplication property. And you can start abbreviating property of equality as POE if you'd like, but that's the multiplication property of equality. And you have proven, you have showed your reasoning, you've done your steps. Why is this true? Why is that true? You've told why they're true. So you actually did the work and you told why each step worked the way that it did. Next problem, you're given that this is true We want to somehow prove that x must be negative 2. So obviously the first step is going to be to get rid of those parentheses. And the way we're going to get rid of those parentheses is by using the distributive property. And you can put the property of equality if you'd like. And then let's see, what are we going to do now? We're going to move my 27 over by subtracting 27 to both sides. So that would be the subtraction property of equality. And that leaves you with negative 18x equals 36. To get x by itself now, we must get rid of negative 18. Since they're being multiplied, you're going to divide both sides by negative 18. What tells you can do that? That would be the division property of equality. And when you do that division, you end up with x equals negative 2. Okay. Next problem, you're given that 6x plus 7 equals 8x minus 17. Again, that is your given. That's always your first step. Now notice what happened. They moved the x's. They moved these 6x's over here with these 8x's. What theorem or what postulate theorem property tells us that we can take that 6x and move it over? Well, since we subtracted 6x from both sides, that would be, again, the subtraction property of equality. Okay, now we're left with this. And notice that what they did was the 2x stayed put, but they took these minus 17s and they somehow moved them to the other side. How did they do it? They did it by adding 17. So they added 17 to both sides using the addition property of equality. So that brought them to this step. And again, they're here because they did this. So you got to be careful. The reasoning for the previous one, you kind of go over to here. Let's start over from the beginning just to show you. So you were given this, you did this, and it carried you to this. Then you did this, and it carried you to this. Now, the reasoning behind what we're about to do, 24 equals 2x. We're going to somehow move that 2 over, and that's the reasoning that we're going to give right here. Since 2 is being multiplied by x, to get rid of it, we're going to have to divide by 2. Dividing both sides by 2, that would be your division property of equality. And when we do that division property of equality, we now have 12 equals x. You might be saying, okay, well, that's what we're trying to prove. Actually, no, it's not. We're given now that 12 is equal to x. We want to prove that x is equal to 12. Well, that's the same thing, and you're right. However, it's written in the wrong order. So we do need to justify, well, why can you just flip that around like you did? And that reasoning would be the symmetric property of equality. Symmetric, or we'll just call it the symmetric property. And I'm perfectly fine now that we know that they're property of equalities. And then what does property of equalities mean? They're equal signs. So I'm perfectly fine with you just saying the division property, symmetric property, or whatever, and so on and so forth. Okay, next problem. Number 1, the reason we know this is true is it is given. So given, you're given that. Now, what we're going to do next, we're going to go down to here, and I believe we're going to get rid of these parentheses, and the way we're going to get rid of those parentheses is by using distributive property. And after we use distributive property, this happens. We've distributed negative 7 and distributed 6. Now the next thing, let's see, what happened here? I believe they combined negative 7x and 4x here was what happened. Now the process here, I don't mind, not really care what you put. You can put one of two things here. You can put they simplified, or you can put combined like terms. Because that's what happened there. They didn't use the addition property of equality, didn't use subtraction property because they didn't do anything to both sides. They simply put those two things together, and it gave them this. Now, next up, now we start moving stuff, and let's see if we can figure out what they moved. I believe they moved this 12x right here. I believe they moved it over here by subtracting 12x. So they're going to subtract 12x from both sides, and that's going to be the subtraction property of equality. And after you apply that subtraction property, it turns into this. And I believe they moved the minus 14 to over here by adding 14 to both sides. So that would be the addition property. So after the addition property, we end up with this. And the very last step is we've got to get this x by itself. Since negative 15 has been multiplied by x, we're going to divide both sides by negative 15. And that the reason we can do that would be the division property of equality. And once we divide by negative 15, negative 10 over negative 15, you could actually throw another step in there. We've got to simplify that fraction, but we will get exactly what we were looking for, 2/3.